Hey everyone, today we are looking at a Roland Juno D synthesizer. This synthesizer's got a couple problems that need some attention. The first is the keyboard. The lower half of the keyboard's actually dead. I've got no sound from about here down. On the right side, the keys that are working, the velocity is not consistent with it. Some keys are basically full on all the time. Other ones they seem weak, you don't get full velocity out of them. It's dirty key contacts, almost guaranteed for those. The rest of it, usually the controller, at least on these synths that I've seen, is split up into two halves. There'll be the upper half and the lower half of the keyboard that has ribbon cables that feed off to the main board. I'm guessing there's something going on with the lower half of the cable. Just a guess. We'll open it up and find out what's going on there. The second issue with it is the volume knob. The volume knob's a little loose there. It still works, so it's fine in that regard, but I don't know if it's probably board mounted, similar to the MC303 was. In that case, it could be a damaged pot that'll have to be replaced. Again, we'll find out once we open it up. The Juno D came out in 2004. It was one of Roland's more affordable synths at the time. I think it retailed just for around $700 US. It still had reasonable specs. 64 voices. It's 32 megs of RAM, over 600 actual samples, PCM samples in here, 16-bit samples. It's got, the keyboard is 61 key velocity. There is no aftertouch. The construction of it is actually aluminum. The whole front's metal, which is kind of nice. It's not plastic. The rest of the frame is plastic, though, and it feels it. The thing only weighs about 10 pounds, so it's very light. The lightness can be a good thing or a bad thing. If you're traveling with it, obviously it's a good thing, but in terms of ruggedness, it's hard to say. It could be one of the reasons why it's not working. I can actually kind of twist the whole thing with my hands just by putting a little bit of pressure on it. And it actually seems a little bit warped because it's not quite sitting on my bench just level. But other than that, the quality of it seems very good. It's got the same Roland buttons on a lot of the equipment from the era. Pitch bender, which is nice. The display is a 2-line, looks like 20 segment or a 20 character by 2-line display. Backlit, kind of orange. So, decent display for this. It's about the same display you've seen on synths for years. You know, everything fancier now has got much bigger, much better displays, but for the purpose of this, it's just fine. So, again, it's working on the upper keys here, but the whole lower half, the key bed is dead. Got nothing. And then the velocity is just not consistent across the keys. But we will open it, take a look. Hopefully it is easy repair. I purchased this one extremely cheap. It wasn't very expensive, even with shipping, due to how light it cost. This is also the first synth that Roland reintroduced the actual Juno name since 1985 when the Alpha Juno 2 came out. So it's been a bit, almost 20 years, since the original release of that Juno compared to this one. And granted, the original Alpha Juno 2 was an actual synthesizer. It did synthesis. This is a sample-based synth, although it does have a lot of digital filters, a lot of good effects. But it is still playing ROM samples. It's not actually doing any real synthesis. We will start the disassembly. The entire bottom of this is all plastic, which obviously makes it light, but also makes it flexible. Set this aside. Alright, take a look. So here is inside the Juno D, and I already see the problem for the keyboard. So this ribbon cable is not going to work very well. It's missing the top portion of its header, and it's completely pulled out of the pins right there. It's really odd. I wonder how that happened. But that will be repairable, so that's good. Now on this synth, the switches for the key bed are on this board here, and this board looks to be on the bottom side of the metal frame of the actual key bed itself, which is good because we won't need to remove every single key to get to all the key switches to clean them on this synth. We can simply pull the key bed off. Looks like we can remove this plastic frame, maybe not. All the springs are on there. I'll have to look at that more closely. It's ideal if you can get to it from the bottom, that way you don't have to remove all the keys. But I may have to on this one, unfortunately. We'll just have to take a quicker look, or a closer look. All the boards in the synth are mounted component side up in terms of the synth, its orientation. So you can't really see much without pulling the boards out. But power supply is over here. This synth doesn't have an internal transformer. There's an actual external 9-volt transformer that runs it. It only draws 1 amp. So you got a simple power supply here with maybe some regulation, it looks like. I'll pull that off when I take this off to take a closer look at it. From there we got our digital board, very common on these Roland synths. It looks like that is also our analog board because that's got our analog outputs here. So based on the traces, we'll probably find our analog circuitry in this region right here. We'll also probably find our DAC right in this region with its pins bridging from the digital to analog side. These will be separate ground planes for the analog power versus the digital power. So taking a closer look at this ribbon cable for the key bed, I'm really confused on how this happened because we're actually missing the piece that connects this ribbon cable to the board here. And this isn't actually a connector either. You know, this side's got an IDC style connector, you know, with pin headers in the board that it plugs into. But this one doesn't. It's almost like this cable was actually just hardwired to this board there. But that piece, I didn't hear anything floating around in this unit. So unless it's stuck somewhere in here or I didn't see it, I'll have to give it another shake and see if it falls out. But I don't know how that would have come off other than somebody going inside this and pulling that. So it's really strange. So I'm going to start pulling this apart so we can work on getting this key bed out of here. This synth actually came apart really easy. Probably one of the easiest Roland synths that I work on. So, this key bed is one of the Roland types that actually has the springs on the rear. A lot of the ones I've worked on actually have the metal springs that are on the underneath it, kind of just a bent piece of metal that produces the springy key action. For these, the springs are on the back, and to get the keys off, you need to remove the rear spring. To do that, you basically take some type of small tool. I like using a dental tool. It's got a little hook on there, and get underneath the spring, pull it off, lower the spring down, and then the key itself will just remove right off. And then once it's gone, you have access down into the rubber membrane key contact, and these will be in strips along here that you'll have to remove all the keys, then you can pull the rubber off, then you can clean underneath it, and that will resolve the velocity issues that this synth is having. The springs are color-coded too, which is nice, so the ones that have more kind of a gold shade are for the black keys, and a little bit bigger silver ones are for the white keys, so you don't need to worry about mixing anything up. So now we actually have access to the key switches for this synth. But I'm going to clean this up a little bit first, because this is any dirt and grime and whatever that gets on the keys will always fall through the keyboard in between them, and it'll end up here on this board. So this part always gets kind of nasty. And when we take these membranes off to actually clean the contacts, we need to make sure everything's perfectly clean. You don't want to get any additional dirt or dust or stuff underneath there. Otherwise, you put it all back together and you find that, you know, there's one or two keys that aren't working, so you have to rip everything apart, take it all back down, and start over again. So I always make sure I clean everything really thoroughly first. these rubber membranes. You just basically gently pull on them. And there's little rubber pins that are placed into the holes on this PCB that keep it in place. So just work along very carefully, making sure not to rip or force it, and it will lift right out. Here's a look of the actual keypad itself. So you can see some dirt and grime and some accumulation of carbon built up on these pads. This is what we're going to clean off. And then we're also going to gently clean the carbon contacts on the board here as well. You need to be careful when you clean these. I use isopropyl alcohol just with a cotton swab, just very, very gently, and just to remove the little bit of residue that's on there. Same with the board. You don't want to rub hard, you don't want to work it too hard, because you can actually damage the carbon surface on these rubber contacts and also on the board as well. So I will go ahead and remove all the rest of these rubber membranes, and then we'll start cleaning. So some of these do look warm pretty bad. More so than normal, which is kind of worrisome. So when putting these key switches back on, you need to make sure you get the orientation correct. If you put it on reverse, it's not going to work. Then to reinsert, you just place the pins back into the small PCB holes and just use something small. Right now I'm just using another dental tool, and just gently push them back in and they will go right back into place. Alright, I will continue the rest of the keypad, clean all the contacts, and then we'll reinstall the keys. So going through these pads, I just found proof that somebody has been inside this before. Looking at the pictures, there was the one key that had kind of a little bit of red marker on there. Well, on the underside, you can see that somebody has put conductive paint onto those two pads. So this key wasn't working, and somebody tried fixing it using conductive paint. It looks like the circuit pen type stuff on there. That's generally how I don't like to fix these. A better way is to actually take a pair of snippers and snip them off. And then grab a old television remote control or some other device that has the same rubber pads like this. Snip those off and super glue them in place for the two that are bad. That way it's the same carbon composition material on there that's making contact with the PCB. I'm curious if this is one of the keys I was having velocity issues with because of that. But at least we know that somebody has been in here, and it explains why that ribbon cable's broke. Somebody probably didn't take it apart properly and ended up breaking it as a result. But so I'm going to leave it as is now. I don't know if that key, I don't know if this key was actually one of the ones that had velocity problems. I think I'm going to move it. No, I'll leave it where it's at. I'll put it back together. I won't completely reassemble the keyboard. I'll test that key, see how it sounds. And if it does have velocity issues, then I'll go about the method of cutting these off and replacing them that way. But mystery solved. So I have the keypad back together. All the contacts are cleaned. The one section that had the bad key is actually, I moved it from this section to this section down here. And it's this key right here. So I'm going to put all the keys back on. But if I'm having trouble with this key still, I'll know it's at the end. I just need to remove this little section of keys here and not have to rip the whole thing back apart. Alright, I've got the keyboard reassembled, all the springs are back on, everything went fine. I'm going to now focus on this ribbon cable to see if I can reuse this connector here, which I should be able to. So I dug through the parts box and I found an old parallel interface, which has the same, it's got the same width ribbon cable as this, and it's got actually the same header as well. So the plan is I'm going to pull the back off of this and see if I can use that to, if anything, it'll help me seat the cable onto this connector, but if I'm lucky it will fit. I'm not sure if it will or not. This is an amp connector. I don't know what that is, so we'll know once I try fitting it on there to see. It's just not the easiest place to get into. Alright, cable seated. If I can get this apart now. So I was able to find a connector that worked. I ended up having to go to a different ribbon cable to get a piece of plastic for the backing for it. So I've just got a couple old PC ribbon cables in a box I've been saving forever. And it turns out that the amp connector, even though it was the right size, the pitch between the pins, the two rows, was too close. So if you compare that to a Foxconn connector, you can see the difference. The Foxconn connector's got, the pins are spaced further apart in terms of the two rows of pins. And this matched up to the connector that was actually on the board. But this ribbon was actually it was too wide, so I had to break the connector off and then cut it down to size. So, and it fits pretty snugly on there. I was able to definitely put some pressure and get that ribbon cable seat in place. So I'm going to test it, and if all's good, I'm going to put some probably some epoxy on there just to hold it in place so it doesn't come off again. While I have this apart, I want to look at the potentiometer for the volume that was broken, which sits right in here. So it's part of this board, which also houses the display. So I'm going to pull this off real quick and see if I can tell what's going on with that. I don't see any broken traces. The pot sits here, though. I can't tell if it's actually mounted to this board or if there's another daughter board underneath there. But I'll find out here in a second. So it is mounted to this board. Alright, so here's the main display board. And looks like it's just broken. It still works, it's just loose. That's going to have to be replaced. I'll have to look up that part number. Something else notable on here. This board is actually labeled RS30 panel assembly. Now the Roland RS50, from an appearance standpoint, is nearly identical to the Juno D. It's a different color, it's gray instead of black, but the key layout, everything else is identical to it. So this board is obviously used in both. And on the main board I noticed an RS designation as well. It's just interesting that they're actually sharing everything in this between the two synths. This is why board mounted potentiometers I don't like. I always prefer panel mounted, because panel mounted you got a metal structure at that point that's actually mounted to the front of the unit, and the odds of breaking this at that point is very unlikely, versus having board mounted with these pots like this. Any hard bump to them, granted it shouldn't happen, but if it does, it's going to damage them. And this is extremely common on the MC series, MC303, MC505. They use all board mounted pots on those too, and they break all the time. And it's a pain because you got to rip the entire thing apart to get to them, to replace them. This actually looks like it's a stereo pot too, based on the number of pins. So they're probably passing audio through this on the way out. So I have the Juno D back together on the bench, at least partially back together, enough to test it. And good news is, the upper half of the key bed works completely now, along with the lower one. So the ribbon cable worked fixed. Every key works. I've gone through every single one, so it's good. The only issue remaining is that specifically the key that had the metallic paint on there isn't working that great, and the velocity on it isn't consistent. So I still want to fix this key. It's intermittent enough that it bugs me. It needs to be fixed properly. So I'm going to have to go in there and I'm going to have to do what I mentioned about cutting the actual conductive pads off and gluing new ones on. It isn't a big deal. It's easy to do. You just have to be careful about it. Specifically in terms of velocity, you need to make sure the two pads are the exact same height, or at least within the same height to each other. Otherwise, this key's velocity will be different than the rest of the keys as you're playing the keyboard, which will be quite annoying. So I will put it back together, or take it back apart, and we'll work on that next. Okay, I have the bad keypad out. It has the paint on there, which we're going to remove. And the way we're going to fix this is I have a section of a remote control here that is good. And I'm going to remove the conductive rubber pads off of this. Once I cut those off, and I'm going to glue them in place with some super glue. So this is really a foolproof way of replacing these. Now, on these newer synths, you might be able to get parts. I didn't check on the Juno D. Roland still may have this. It might be used on synthesizers for years. They may still have some in stock. I don't know. On older synths, you don't have that option. When I did my D70 rebuild, you know, this part is obsolete. Like, they were sold and long gone years ago. So if you will need to repair this and you have problems with the pads in a synth like that, especially older vintage synths, you either need to get a donor synth and steal parts out of it, or you need to possibly pull a rubber membrane out of a different synth that may be compatible with the synth you're trying to do. You might need to modify it, but it will usually work in some cases. Or you need to repair it this way. And this is the way I'm going to do it, just because I have this on hand. I've done this before. It works really well. So I will show you how. So step one is to cut. You just want to remove the top conductive portion on these without going too deep actually into the rubber itself. So a sharp pair of snips is all you need to use. Just like that. Next, you do the same for your good key pad. Just cut. And cut. If you're doing this with an old used remote like I am, pick buttons that generally don't get used that often. You know, some weird setting or something like that. You know, don't pull the volume or channel pads off of there, because they're the ones that get used most of the time. So I'm going to take a look at this and just make sure they're level. So next step is you glue. You just need a tiny little bit on there. So I'm just going to use a swab here that I cut off to actually place the glue. And then gently place the pad. Same for the second one. And that's it. So you just let that dry. It generally sets pretty quick. But you can see that's why you want to make sure you cut them right at the top, because you still need to maintain the distance between the two in terms of velocity. If you get those distances too far off, when you strike that key, it's either going to be too quiet or it's going to be too loud based on the velocity in relation to the other keys around it. So I'll let this sit for 5 or 10 minutes, let it set. This glue sets pretty quick, and then we'll throw it back together and give it a test. A quick note on this ribbon cable. I threw some epoxy on each side there to hold it in place, so just to make sure that this black piece doesn't fall off from vibration or anything in the future. While we have this back open, I figured it'd be a good time to take a look at the boards inside and just see what components they have running this thing. We'll start with the power supply. Again, there's not very much here. This unit has an external transformer, as I mentioned, driving it, so very, very minimal power supply. So your DC input, you got some really basic input filtering here. You've got a tiny little choke, a couple filtering capacitors, your power switch, protection diode right there, and then a 7805. In this case, they're using a JRC component, which is kind of cool. Besides that, you've got filtering with a couple electrolytics here on the output. So they are both 85C rated. This one's a Nishikon, smaller one. That was a microfarad at 6.3 volt, which is probably on the output. And then the bigger one, 2216, is on the input. I don't see a brand on there easily detectable, but at least they gave a little bit of space between the heatsink and them. I'd still like to see these caps sitting way over here, as far away as possible, but I can't imagine the heatsink is very hot, so it's probably fine. Again, being 85C rated, as well, they probably know it's not going to get that hot. You'll notice on the board, too, that there's actually an outline for a bigger heatsink and also a possibly bigger protection diode here. Yeah, same traces. So this power supply was probably made for a range of synths that Roland made at the time. They gave it a RS name as well, so just like the main board, there's a couple RS series synths that look identical to this one. So I'm sure they use the same boards in those, along with possibly other Roland gear too. But it's a super simple power supply, nothing special. So moving on to the digital board. There's a little bit more going on here. So here's a look at the digital board out of the Juno D. Again, designation on here RS30, same as the power supply board. So this was designed to work in very many synths. It is all sample based too. There's no actual synthesis, as I mentioned, out of this synthesizer. Most of the actual work is coming out of this section here, because this chip is your master DSP and sound generator. So these chips are all Roland part numbers. You can't really find any data sheets on them, but just by observing the board and the surrounding area, you can kind of tell what's going on here. So we've got RAM for the DSP here. We have two ROMs, basically flash. This one is our sample ROM, and you can see you can expand this to 2 to double it out. I believe this unit had 32 megs of sample, so it could be expanded to 64. And then this flash ROM here contains the actual OS for the actual unit in terms for it to operate. Right next to this chip, we've got our DAC. It's an AKM AK4324. This is actually a 96 kHz 24-bit DAC, so quite impressive stereo as well. Roland has used many different DACs in their equipment. All the older stuff had Burr Browns, which was kind of the industry standard at the time, and they expanded out from there using a couple different brands. This is the first one I've seen using this specific DAC in terms of the AKM brand. Specs are pretty impressive on it. So it's got 105 decibels of dynamic range. It again is 96 kilohertz, up to 96 kilohertz, up to 24-bit. So powerful unit, good specs on it. Probably not a super cheap part at the time. On the output of this DAC, we've got our filtering, consisting of op amps and caps in here, and then a lot of just small, probably op amps on the actual drivers for the actual audio output through the stereo and mic jack, or the headphone and stereo jacks here. Moving on to this side of the board, again we've got 3 Roland branded chips. So I searched, I couldn't find any information on them other than people talking about them, kind of questioning what they were as well. But based on the layout, I can kind of conclude of what each one does. So this one in relation to the crystal, and also there's also a tiny little crystal driver here too. This is probably some type of clock generator chip. So off this crystal here, it could either be dividing the clock down, raising it up, or it might just be passing through there for some EMI suppression. I'll actually have to look at the number and see what that chip is. But this chip is most likely the CPU for the unit. So it's handling the display driver, it's handling driving the display, it's handling the communication between the DSP and user functions and various things like this. Over here, this chip is actually most likely reading the front panel SKICAN codes. So these 2 ribbon cables here go to everything on the front panel. It goes to all the potentiometers, it goes to all the switches in terms of the matrices that run the switches. So it's probably doing all the scanning. And then it may be doing some analog digital conversion off those pots as well. I don't remember seeing any ADD chips on the front panel. And those are actual analog pots. They're not digital encoders by any means. This chip over here is handling the actual keyboard scanning. So this connector goes to the keyboard. This must be handling the actual, on-off detection of all the keys, along with the velocity calculations for, between the two sensors on each key. How hard you're actually pressing down on it. And then all of this is communicating back to the CPU, which is then relaying the information to the actual sample playback ROM and DSP. And DSP in this too, there's a lot going on in terms of DSP, looking at the actual manual for it, and just using it. The real-time filters on here, the resonance and cutoff filters, you can adjust those in real time. And there's no digital artifacts when you're using them. It's a very smooth sound, almost like an analog type sound, as you're adjusting those two filters. The effects processor in the Juno D too is actually pretty extensive. A good third of the manual just goes into going through all the different delay and distortion, overdrive type effects, along with all your reverb and other type things. And you can actually chain those together in various methods. You can have one chain into the other, you can chain them parallel, you can chain them serially, you can then cross-chain them together. So there's a lot of different routing options inside this unit in terms of the built-in effects, which is pretty neat. So the DSP there obviously is handling a lot of that processing. There are a good amount of components that aren't populated in this board. Two ICs here and here. We have a whole section of components here, a section of components over here, that second connector, what looks to be a little power supply circuit over here. So whatever other models that this was used in obviously had additional features that we're not finding in this Juno D. Alright, we have the Juno D back together, and the moment of truth. So we look good. Velocity seems even between the keys. This was the one I had replaced. So I think we're good at this point. I'm happy with that. So I'm going to put it back together. Again, I just basically screwed the minimum amount together just to be able to test it. So I'll put it back together and this will be done. I'll finish cleaning it up a little bit too. But I did order this volume pot. It's going to be another week or so before it gets here. I'm not going to delay waiting this video to post how to replace the pot. It's trivial. It's basically the same method on the MT303 I did. It's just a board mounted pot, nothing special. So that is it. I hope you enjoyed this video about the Roland Juno D, and thanks for watching.